everyone. I hope the audio is clear. Okay, today we are going to discuss about an IoT project that is nothing but greenhouse monitoring using an IoT with a MQTT protocol. Okay, so before going to the starting, so this program is sponsored by an IETE, the Institute of Electronics and Telecommunication Engineers, and the outcomes of this entire project is, so if you want to demonstrate any output or any project, so we need to follow the academic outcomes. The academic outcomes we are following is objective. So first we need to be aware of our project and then existing system and then literature survey. So what are the previous existing projects and all, and the proposed method, block diagram, modules, like what are the modules under this project, we need to divide it into the modules, and then circuit, and then project demo. Okay. So today's our project is about to greenhouse monitoring using IoT and with an MQTT protocol. So before going to that, let us give you a brief review on about agriculture monitoring. Okay, first we'll go to the base paper and first we'll study our paper, and then so here I am taking an IEEE project. So the greenhouse based IoT and here for the social benefits. Actually here in this project they are supposed to use an LPC2138 microcontroller, that is nothing but an ARM microcontroller. So by taking that ARM, they are adding some different kinds of sensors, and for forecasting purpose, Wi-Fi module and all, they are going to use it. So but as of now I am going to work with a Raspberry Pi device which make our project very simpler way, and the latest version we are going to use the Raspberry Pi 4. So here we are going to use today Raspberry Pi 4, and here they are depending upon a web page. So a web page based creating system they are supposed to use, but there are some limitations for the web page, that is nothing but a local host. So within the range they are going to update the values, but there is no cloud security and all. So now we are going to add a cloud in the proposed system, proposed method. So generally, so before going to discuss about a literature review, first I just give you the what exactly the greenhouse and why everyone preferring, why we need to maintain the greenhouse and all. So what is the greenhouse and all, we will see first. So greenhouse are controlled area environment to grow plants. So it is a structural building which different types of covering materials such as glass, plastic, roofs or any walls. So inside the indoor environment we are going to create an indoor greenhouse environment which will make us so pleasant and all. So but the indoor environment, indoor gardening system should be maintained in a proper way, because the sunlight should be a proper, and the temperatures of the room temperature should be a normal state, and it should be constant, and the sunlight absorption and the soil content, soil moisture content. So there are lots of parameters shown impact on a inside gardening systems or inside greenhouse systems. So but nowadays due to the population increasing and all, we are customizing or we are decreasing our things, gardening systems into our homes and all. There are a lot of changes will come. So now we need to maintain our garden in a proper temperature which is not similar to the outdoor. Okay, so that's why we are coming with this. Here you can see some examples, the greenhouse, like how it is going to be. So this is about the nursery. So nursery also they should maintain inside the roofs or any plastic roofs only, they are going to maintain the entire parameters and all. So to avoid that, we are supposed to use this greenhouse monitoring. And now we are entering into our main motto of our project. So now here the main motto of our project is build, maintain miniature garden systems which is equipped with the automatic monitoring and controlling system. Right, if you are supposed to working with an inside gardening system or greenhouse systems, we need to maintain present temperatures, light intensities and soil moisture data, and the humidity of the room temperatures also we need to focus. And it focus on saving water consumption also we should be aware of that, and increasing efficiency and reducing the environmental impact on a plants reduction. So is there any environmental changes, it should not affect, like for suppose the humidity is very high, it should not show impact on our greenhouse plants, because we are not that much aware of maintaining indoor gardening systems or greenhouse systems. So by using these automatic systems we can be able to control very easily. Okay, so now we hope now our main motto of introducing this project, everyone got this point. So now we'll get into our base paper, our reference paper. Yes. So here, so many of past 2 decades onwards, they are supposed to use the gardening systems and all. Okay, so here to maintain the parameters we are going to use some sensors, soil moisture sensor as usual they are using, and they are separately using LM35 sensor, right? I just maximize it, right? Okay, so here soil moisture sensor, temperature sensor and LM35 sensor they are using. So because by using this LM35 we may not get the accurate parameters like room temperature, ambient we are not getting. So I just want to replace this LM35 with a DHT11 sensor which will measure the both temperature and the humidity as well. And then I am supposed to use the CO2 levels in the greenhouse effects. So this is also maintaining create impact, right? And here they are supposed to use one water pump. Whenever the soil moisture is dry, it will automatically get it, and one exhaust fan. Like if there are any abnormal CO2 levels, gas levels, the exhaust fan will activated and it will get into that. We know that the advantage of using exhaust fans, right? So whenever is there any abnormal in a CO2 level in a particular room, it will the exhaust fan will analyze. And then Wi-Fi module to connect the IoT, we required an internet. So that's why we are supposed to use ESP8266 Wi-Fi module in this block diagram, in this particular reference paper. But I come to know that we are going to use the latest microcontroller, nothing but Raspberry Pi device, and then which is having an inbuilt Wi-Fi module. So we don't need to use an external things and all. And raindrop sensor also. I hope raindrop sensor is no need, because we are supposed to use the indoor systems, right? So that's why I just removed that raindrop sensor or rain sensor. We are going to use an indoor greenhouse systems. So no need to maintain the raindrop sensor, rain detection information and all. We are completely eliminating those. And these are the things related to this. So now get into our project. So these are the drawbacks which I studied in this paper. So I take the 2020 latest IEEE transaction paper. So I got some issues in this. So I just want to eliminate those and and we are going to do the our project very effective way. Okay, so automated greenhouse. The features of an automated greenhouse forms is important part of agriculture and horticulture sector of a country. Actually nowadays there is a lot of everybody are focusing about an horticulture in our India, because when compared to the regular food products and all, they are supposed to depending upon horticultures. So we need to maintain first the planting, seeding and nurseries. So if you want to do this kind of horticulture systems, first initially we need to depending upon the drip irrigation systems and all. So that's why if you are introducing a greenhouse effect systems, it should be very useful. Those who are maintaining the nurseries very effectively, they can get the maximum outputs and every plant should be grown healthy, and they can be used the growth plants under controlled climatic conditions, right? Just now we discussed, right, we need to maintain every parameter normal. So it is not only monitoring, we are supposed to controlling those parameters also effectively by using smart and this greenhouse systems and controlling also. In order to control the climate factors and environmental autonomously, it required a computer software or some equipped device. So that is nothing but sensors, actuators and the controller. So we'll see the benefits of this system. So automatically control environmental conditions with greenhouse, allowing by type of plants to grow all year around. So for suppose so many of we are thinking only this particular months only we are getting winter season, some seasonal fruits or seasonal foods kind things are there. If you are maintaining a greenhouse system, irrespective of the your seasonal things, you can be able to maintain those environment according to the requirements of the things. So that is an importance of greenhouse and horticulture system. So horticulture in the sense, suppose you want to build a tea, here that tea is not grown, right, but we can able to gain by using greenhouse systems to maintaining the same environment, convenient environment for the tea to grow the tea. So minimize the labor cost including maintaining a greenhouse. So we are supposed to maintain the greenhouse by watering our plants by using soil moisture sensor and all, and then customer able to define the specific greenhouse conditions. So according to their convenience, for suppose we have any fruits, apple, these kind of things, or tea, or according to their convenience we can able to adjust the parameters in the greenhouse or sensor sensibility we can able to vary. Plug in and plug out product, it should be very easy to control and all, and these are I'll tell you later about this. And now in this project we are going to suppose to use hardware requirement. So here I take some limited sensors, only one sensor I just miss it, remaining I will have temperature sensor and the humidity, both DHT11 sensor and gas sensor, CO2, MQ2 sensor I just take it, and then soil moisture sensor which is having a comparator also, and then motor, and then Raspberry Pi device. Okay. I just show it what are the components I just taken by me. Wait. I hope it is visible to everyone. I just take the Raspberry Pi 4 device. This is the Raspberry Pi 4, and then CO2 gas sensor I just take it, and this is an ADC. So analog to digital converter I just take it, ADC, because all this Raspberry Pi GPIO pins, general purpose input output pins, are the 40 pins. So that's why I just take an ADC, and then comparator for the soil moisture things. This is the soil moisture. I'll show you while showing demonstration. I'll just explain one by one. And then DHT11 sensor, both measure temperature and humidity. So here I didn't keep any exhaust fan or anything. We can keep it in a real time. Just I show you 5 voltage DC motor. Here I just keep it. You can keep an exhaust fan if you want. I just simply keep one motor for the temperature abnormal condition. So only one condition I made here. According to that condition, we can do able to perform. Okay, so these are the things I am going to take today. These are the components. And coming to the software, we are going to use Python IDLE software, and then TeamSpeak, and then MQTT app also I didn't mention here, and then Raspberry Pi OS. So the Raspberry Pi will work on one particular OS operating system. So that is called Raspberry Buster OS Attack. And this is about the block diagram. DHT11 sensor, soil moisture sensor and gas are connected to the Raspberry Pi. So based on these parameters, the fan is going to be controlled. Remember, this is not an automatic. Actually, there are lots of disadvantages on an automatic system. For suppose previously in a previous projects, we can see whenever the soil moisture is dry, automatically the motor or a fan, the motor will get rotated, right? But the disadvantage of motor pump rotating is irrespective of the weather or irrespective without unknowingly also, sometimes we have wantedly make our fields or make our things dry, right? There is some situation our machines or our things doesn't understand those. So for that purpose, if it is getting things like in a cloud, each and every data is uploading. So based on those parameters, I can be able to control my motor or fan or output devices. So here I just take one motor. You can use exhaust fan, and you are going to use in real time. Like if you are supposed to get this project, we have to compulsory use one exhaust fan and one pump motor. So to replace those, here today I am going to use a single motor to show the demonstration purpose. I don't have an exhaust fan, sorry for that, I can't able to show it. And then all the sensors in the block diagram mentioned above should be interfaced with the Raspberry Pi. So Raspberry Pi is a controller, miniature computer. Code is written in a Python and data is sent to the TeamSpeak, and we can data remotely through the cloud. We can see the data remotely through the cloud also, even like at particular what time the temperature of that particular room, and at what time the soil moisture is dry. So with respect to time analysis also we are supposed to get it. And this is about Raspberry Pi. These are the modules, Raspberry Pi, DHT11 sensor and all. So I don't discuss about Raspberry Pi much. Already in a previous videos we are so much discussing. Okay. And then DHT11 sensor. So the humidity is measured for water vapors present in air. The level of humidity is air affect various physical, chemical and biological process. In industrial applications, humidity can affect the business of cost of the product, like health and safety measurements of an employee. So the semiconductor industries are generally we need to know the humidity of the particular room temperatures, right? In a particular room or anything in industrial areas and all. So here also we need to maintain the proper humidity level or proper temperature levels in our room, in a greenhouse. So that's why we are going to supposed to take this DHT11 sensor. And here I am taking the ratings of the DHT11 sensor is a 1 wide. A pull-up resistor 5K to 10K ohm is provided in a communication between sensor and the microcontroller. So here if you see the DHT11 sensor, you can able to see the 4 parameters. One is pull-up resistor pin number. So mostly we are avoiding those. We are directly connected to the resistor, and remaining 3 VCC, that is nothing but 5 voltage supply, and ground we are going to connect with the ground, and then data pin. So the data pin we are going to connect according to the pin number. Any GPIO pin number you can connect. So one more most important thing is DHT11 sensor is about to digital sensor. It's not about to analog or anything. It is a digital sensor, one wire system we are using. So in a Raspberry Pi device we are going to enable the one wire. In a Raspberry Pi configurations you have to enable the one wire system. That is nothing more than that. and the gas sensor. We have so many of gas sensors. Under gas sensor we have different kinds of family from MQ2 to MQ9, 9 I think so, 9. So ideal sensor for this detecting the presence of dangerous LPG gases or any storage tank environments or whatever. We have so many like carbon dioxide, methane gases, LPG, alcohol. So all these are comes under same family, that is gas sensor, MQ family we call it as MQ family. So here today I am going to use about MQ2 sensor I am using. And the next sensor is about to soil moisture. The moisture of the soil plays an essential role in So basically here we have two nodes, two electrodes. So based on the two electrode difference, we are going to measure the electrical resistance between the two dielectric constants. So whenever you are keeping soil, the dielectric constants in the soil, it will create some electrical resistance based on the dry and wet. The dielectric strength is different between dry, when the soil is dry, and then when the soil is wet. So based on those parameters we can be able to keep it like this. So these are the two dielectric constants. So whenever you are keeping wet here, the dielectric constant or resistance should be varying. And this is about motor. So without doing any delay, we just go to the practical. So then I'll explain one by one. So then you should be aware of. I have a kit with me. So I just explain to you like one by one. So the steps we are going to take. So our very first step is we are going to connect our thing. So I just made the connections and everything. It will take time. So that's why first initially all the digital pins are connected to the IC. And not directly connect all the sensors to the Raspberry Pi device. I hope it is visible. Okay. I am not directly connected to each and every sensor to the Raspberry Pi device. In between, I am using ADC, analog to digital converter, because all these are the GPIO digital pins. So I will just use an analog converter. So this is a comparator for the soil moisture. So I just told you, right, the dielectric strength between these two nodes, these two electrical resistance should be measured by the comparator. So here we have a comparator. The comparator will compare the two the things between here. Some from VCC reference voltage we are going to give, from that to it is getting. And another is MQ2 sensor, gas sensor I am using, and this is the DHT11 sensor, and this is a motor, a small motor, 5 voltage DC motor. I just take it. Actually here we have to keep the exhaust fan. So here as of now I don't have that, so that's why I just simply replace with this. So now I am going to give power supply to our Raspberry Pi device. Okay. So now we have to connect through VNC viewer. Because here we are going to connect any monitor or anything, that's not an issue. But the thing is here, this is a OS, the Raspberry Pi OS we are going to get. So here in the back side I have an SD card. So I just burn the OS into that in the disk image file. So I just connect my SD card to the Raspberry Pi device. So then it will act like a OS. So now it's too difficult to install the software or anything. So using VNC viewer, we are going to write same image on a VNC viewer through the same Wi-Fi network. We are going to see. Okay. So for that purpose, I just go to the VNC. So while doing this process in a Raspberry Pi device, you must have to enable the VNC viewer. Real VNC. I already installed VNC in my PC also. So now here we have to type the IP address. So whenever if you go to the Raspberry Pi configurations, you just click on IP, DT-IP, then you got this particular IP address and you have to paste it here. 192.168.2.10. So my Raspberry Pi device is this. And then it will ask you user ID and password. So I just go through this and then user ID I just make it and then password. That is it. So now I just keep the OS. It will take so much of time. Previously we tell you how to install in previous webinars, how to install the OS and what exactly the Raspberry Pi, the internal architecture of a Raspberry Pi device, everything clearly explained. Those who need a in-depth step regarding this Raspberry Pi 4 and the OS installation process, you just go through the back videos and just once watch those, then you got a clear entire picture. Okay. So now we are going to get into our code. So before getting to the code, first we need to choose one cloud, right? Just now I tell you about cloud. So we need to upload all our data into the cloud. So for that we have to choose one cloud platform. So we have the different kinds of cloud. For suppose Google Cloud. Google is a cloud. We are uploading all our photos into that, and wherever you require, you just download it and make a photo, hard copies and all, certificates and all. So in the same way, our data should be uploaded to the Google. That's one platform. And then Azure Cloud, that is about to Microsoft. And then major AWS Cloud, Amazon Web Services Cloud. So all those are there. So here I am supposed to use the ThinkSpeak Cloud because it is very familiar for the students, which is user friendly for the students, and it is a free of cost, easy to handle those. So that's why I chose this platform, this cloud, ThinkSpeak Cloud. So first we have to create an account into the ThinkSpeak Cloud. So I already have an account. So you don't have an idea how to do this, the same, you just go back through the videos. So thinkspeak.com. It's very simple. First you have to fill your details and it will ask you the mail verification. It will ask you to send the mail verification. So side note, I already have an account, I think so, it is created. Okay. So here I already created greenhouse, one channel I created. So greenhouse monitoring. I'll show you how to create. I just delete this channel and I'll just tell you how to create this. Okay, but why I am deleting means up to 4 channels only I can be able to create. So now new channel, and here I just write greenhouse monitoring, and the project is monitor the room temperatures. Monitor the parameters. We have different kinds of parameters, right? Okay. And then field 1 is about to temperature. and then field to humidity, and then gas, CO2 levels. Gas is nothing but here, and then we have soil moisture finally. And then save the channel. So now here it will created the fold: temperature with respect to date and time, humidity with respect to date and time, and here monitoring the parameters, greenhouse parameters, and the private account greenhouse monitoring project. Okay, 4 parameters I am taking. Actually we are going to supposed to take light intensity also. I don't have an LDR sensor, so that's why I skip that sensor. Only single sensor I just skip. So remaining you have to add one sensor and one exhaust fan. So I skip those two because I don't have any sensor, those two sensors. And now I just log in. Now I'll open the code. So this is the main code. So now we are going to supposed to connect this ThinkSpeak to our code. So here by using API key we are going to connect. So the API key of this particular field is, particular channel is here. So I have to copy this particular channel in a code. Okay, the fertilizers are ready. We call it as a gas. CO2 levels is 13. So if you are increasing any CO2 level, so here I just take some thinner to show the smell to that. So then the temperature, the thinner smell it will came. Now it is 112. The fertilizer values is becoming 112. The CO2 level will be increases. And soil moisture is 1023. Actually I show some smell marker or any smell. If you are showing some thinner smell, it will be increasing. So now just I remove this. If you want, I just enable the camera, I think, to just see it in a here. And I just pour some water on a soil moisture sensor to check the parameters. Okay, and just water cup, I just keep this. Okay, now the soil moisture is 427. So here connected to the result code, that means MQTT is connected. Okay, so now the soil moisture fertilizers is detected and 14, 17. So the temperature is 28 degrees and the humidity of the room is 38. Okay, so now the soil moisture is very low, 14.8. If I remove this, now 1023. The dielectric medium is not dielectric is not created. See here also the parameter is varying. So when I remove this, it is showing dry. Soil moisture is 1023. The maximum value of the soil moisture data, analog data, is 1023 because it is an 8-bit ADC, 8-bit analog to digital converter. So that's why it is showing. So when I keep this, the dielectric resistance will create, that is about to the, it is converting into the analog data and it is showing some values 468 and all. Okay, now it is connected. By using MQTT, I just control the motor. So here I just connected the MQTT code here. So now MQTT means MQTT works on based on publishing and subscribing. So here the subscribing topic is greenhouse. Okay, so I have to publish topic based using greenhouse. I hope it's visible to everyone. Wait. So I am going to turn on a motor according to the MQTT commands. Okay, I installed MQTT app in my phone, my MQTT, and I am going to connect. First it is showing the red status. I hope it is visible to everyone. It is showing the red status. So now I just need to do settings, and I need to, this is a constant, broker.mqtt dashboard.com, and the server number is 1883 sorry, and we have to save successfully and connected. Now the status is converted to green. So previously the dashboard is, the broker is showing here, dashboard is in a red color. Now it is connected. So now I want to publish the data. So on which topic I want to publish the data? In a code I mentioned here, greenhouse. So here the topic is about to greenhouse. So the topic is greenhouse. And the message. So here I just write, when the message dot payload is equals to turn on. When I receive the turn on command, then the motor should rotate. So now I need to publish the data to the topic called greenhouse, and the message is about to turn on. I hope it is very clear to everyone. Turn on, and I am going to publish this. Before going to publish, I just open our result, so we can be able to see very easy here. See here 151023, it is showing the constant value. If I keep it here, okay, turn on. So now I'll publish this. Now the motor is rotating. It is showing turn on. Here I just supposed to forgot one time, so that's why it is printing those many times, turn on. Now the motor is rotating. You can see clearly here in the picture. So by using MQTT, so the advantage of MQTT is irrespective of the network. There is no need to particular thing. My mobile is should be connected to the same network. The Raspberry Pi device network is different, and my mobile network is different, but I can be able to control this motor or exhaust fan, whatever. Okay, according to our commands, we are going to publish to that particular topic the data. Okay, so here I got some motor is rotating, and then now we need to see whether the data is uploaded to the cloud or not. I just go to the private view, and here each and every data is uploaded. See, the soil moisture data 1023, now it is about to 509. Okay, we see here 509, next 507, it will be decreased to down 507. See clearly. So now still the motor is rotating. So according to my convenience, I just want to off. So if I send any data, it will stop. Now the motor will stop, because I write a code. If message equals to turn on, then motor will on. If the message equals to turn off, the motor will, apart from the turn on command, if I pass 0, 1, 2, 3, whatever, it will turn off the motor. According to my requirement, I can be able to do any kind of things. And then, so still now we are working on like all the data things and all. Okay, so now we are collecting some data on everything. Then we need to focus on a prediction. Okay, now I collected some data already. We are doing in a web page also, in a IEEE paper also we are did the same thing. So here we need to analyze the data, or we need to predict the data room temperatures. If I give some room temperature, it should show abnormal or normal things. So for that purpose, we are going to apply our data in a machine learning technique. So how to collect our data in the form of CSV file? Just go to the data imports and export, and then click on download CSV file format. Okay, so now fits CSV, show in folder. Export recent data. You just go to the export recent data and then all CSV file format. Actually, I don't have this Excel sheet on my Raspberry Pi, so that Microsoft Excel is not there, so that's why it is not given in the form of Excel. Actually, it will give in the form of Excel. Okay, so now instant data is every uploaded. So now we are going to apply to this machine learning technique. I just quickly show you the review regarding this. Just demo, I'll just show you. So before going to show the demo, I have this in a Jupyter notebook. I'll just open Jupyter notebook to apply machine learning techniques and all. So I'm going to open Jupyter notebook. Yeah, the feedback form link will be shared soon. Last 10 minutes we are going to share the feedback link. So please be patience. Still the session is going on. We will share you the feedback form in the last 10 minutes. I'm going to just open the Jupyter notebook. Okay, it will take a while. So here this is my file feed. So this is the data I collected with respect to time previously. The temperature, I just take only the temperature parameter 35.73, 35 point. I think in a 4th month I just collected this data at the time. So with the data I just do the analysis. Okay, I just collected that data and this is my code. We are going to apply machine learning techniques to the real time data. So then we can able to the machine will predict the weather forecasting and whether it is working good or not, and the temperature is normal or abnormal and all. So here we are supposed to import the necessary modules. So for machine learning techniques we are going to use Seaborn, Matplotlib, NumPy, Pandas. So these are the major things. Pandas to read the dataset, and NumPy is for the numerical Python, and then Seaborn is for the graphical representation and all. And here we are importing the data. I will just run one by one, and then I just call the entire data fed5.csv file, and it is printing the data, top 5 data, the temperature. So here I am going to apply the supervised learning. So that's where maximum and minimum values. just give the train data and input or output for both. So in supervised learning we have to assign the output also. If the temperature is greater than 30 degrees, that is a maximum temperature. If the less than 30 degrees, that is a minimum temperature. The normal temperature, abnormal or normal temperatures, right? If the less than 30, that is normal, that is a minimum temperature. Greater than 30, that is a maximum temperature. And if the room temperature is 30 degrees. And the type A. And then data set. So how many types of this it is showing, and this is the info about that. And the classification, how many maximum values and how many minimum values in our data. The maximum values presented is around up to 60, 0 to 60 values, 60 degrees centigrades also we are getting, and a minimum is 25 or 29. It is in between 20 to 30. And then sklearn package, we are for classification purpose I just take it, and labeling. And now for this data we are going to apply the algorithm. So here I applied random forest algorithm model. I directly using sklearn package, I just directly load the model. So random forest classifier. So for this model I am going to apply our data. So this is our data, the new target data. So directly imported here. Okay, so now, so here I am just going to give you an input. So input is 29.9 degrees, then it should show the output. See, you entered a minimum room temperature, and now the machine will predict those things. If I give 35.7 something, it is the abnormal temperature. That means your room temperature is here. So it will predict. So I give some temperature 35.7 or something. So now the model will predict this. Output is equals to model dot predict input 1. So it should predict the output according to the input. So I gave some input. So now my machine should predict this. So my model will predict it is a normal temperature or maximum temperature or minimum temperature, like this. And this is an accuracy, I got 1 accuracy level. Okay, so this is about the project. So any doubts or any queries regarding project, you just give your comment. Okay, for more interesting projects, like you can reach us. We are supposed to provide our services final year and mini projects and major projects, and even we are support for the researchers, those who want to do the research projects. We will help you, and we are providing some training methods like internships and certification training programs, and STTP short term training programs and workshops, activities, and some hobby kits also we are ready to provide you. And we have branches around Pan India, Chennai, Hyderabad, Vijayawada, Trichy, Coimbatore. You can reach us through according to your locations, and even online support also will be available. Just please reach us, any technical support or anything. Yes, this is the end of the session. We'll share you the feedback link within an hour in a comment box, or you can see tomorrow also. Tomorrow morning also we'll update it within hour, or tomorrow morning we'll update the feedback link. Sorry for the technical issues. Due to some technical issues, we can't able to provide you the feedback link as of now. Definitely we'll provide you within an hour or tomorrow morning. Thank you all. Thank you. I hope you are enjoying this session. If you like this project, you just give a comment and you just give like to our project. Thank you everyone. Thank you.